Hello and welcome to another video on logarithms. Let's say that I have the expression 5 raised to the power of log of base 5 of 125. What does that equal? Well, let's do the log first. So that basically asks, what is the exponent or index of 5 I need to get the answer 125? And the answer to that is 3, because 5 times 5 times 5, which equals 5 to the third power, is equal to 125. And we covered how to understand this sort of terminology in our last video. So log to the base 5 of 125 is 3. So that means we have here 5 to the third power, which is equal to 125. Okay, let's have a look at a second example. Let's say that I have the expression 10 to the log of base 10 of 1000. What does that equal? Well, we know that log of base 10 of the number 1000, or in other words, what index of 10 do I need to get the number 1000? That is equal to, again, 3, because 10 by 10 by 10 is equal to 10 to the 3, and that equals 1000. So that will give us 10 to the third power, and that again would equal 1000. Do you see a pattern starting to emerge? Let's look at a final example. Let's say I have the expression x to the raised to the log of base x of, say, x to the fourth power. And what does that equal? Well, log to the base x of x to the fourth power is simply asking what index do I have to raise x to get x to the fourth. And the implicit answer is the number 4, as, again, x times x times x times x is equal to x to the fourth. So that will give us the answer of log to the base x of x to the fourth equaling x to the fourth. So I see a pattern where the 5 and the log 5 actually cancels each other out, and our answer remains within the log itself. Again, our base of 10 and the log of base 10 cancels out, and the solution we require lies inside of the log. And similarly for the x, and the log of base x cancels out, and our answer lies within the log. So generally, then we can express a to the power of log to the base a of some number, let's say y, is equal to y. So let's do an example of that. Let's say I have log of 3x minus 1 equals 1. Now, whenever I have log without anything, it's always assumed that it is log to the base 10. So log to the base 10 is abbreviated to just log. So now if I was to manipulate this equation and say I'm going to raise this log as a power of 10, so I'm going to say 10 to the log of 3x minus 1, and what I do to one side of the equation I have to do to the other, so that will equal 10 to the 1. So this 1 will also be raised as an exponent. Now, manipulating this equation further, I see that these can cancel out, so I'm left with 3x minus 1 on the left hand side, and that equals still 10 to the 1. Well, 10 to the 1 is just equal to 10, so I can rub out this, erase this index here. And now I just have a normal linear equation to solve. So if I was to add 1 to both sides, I would get 3x is equal to 11. And now if I was to divide both sides by 3, I would get x is equal to 11 on 3. So I hope this video has better helped you understand how logarithms work. If it has, please give me a thumbs up. If you are still having trouble understanding, please comment below and I will endeavour to sort out your query in my next video. In the meantime, thanks for watching and I hope you've learned something.